So yesterday, here's where we finished, and I'll put this back up here. The average acceleration of the object on the interval 1 to 3 seconds. I settled on this. I said that it was v of 3 minus v of 1 over 3 minus 1. But I know as we left, there was at least a couple of folks that were like, no, I totally thought it was something different. So I don't know if there was any discussion that kind of got cut out yesterday that we could continue on today. Nobody's jumping up with a question. Let me just say this. Let's start off with this as far as review goes. If I gave you a position graph and I asked you for something about velocity, what would you be doing to the position graph? Okay, doing a derivative. Or if I just gave you a graph, what would you be working with? The slope, right? Which could be a derivative. So the slope of position will give you information about velocity. Well, what if I had a velocity graph and I wanted to know about acceleration? What would I do? Do the slope of that, or maybe a derivative, depending on the scenario. So in A, it said, what's the average acceleration? So if you've got a velocity graph and you're looking for the average acceleration, you're really looking for the average slope of velocity, which is nicely stated up there. Did anybody get a numerical answer for that? We didn't quite get to that yesterday. Wasn't it like 4.9 or 4.8 or something? I think it rounded the 4, rounded to a 5. Does that sound right?
I got 0. Oh, it did. It did.
It did? Okay.
It was 0.1049.
So let's talk about that real quick. Would it be fair to say that in our class so far, we have done almost nothing with decimals? Would that be a fair statement? So this is one of the very first things we've done with decimals. So I want to give you just sort of some really important information about how we handle these. In our class, I'm going to scare some of you when I say this, and I'm sorry about that, but I'll make it all better here in a second. In our class, we do deal with sig figs. A couple of people got scared looks on their faces. I get it. The good news is in our class, we always have the exact same number of sig figs every single time. 3 decimals to the right of 0. You need to be accurate, rounded, or truncated 3 places to the right of the decimal. So if I gave this answer, I'm 100% correct, full credit, right? If I gave this answer, 100% correct, full credit. Yeah, 3 places to the right of the decimal, right? And honestly, if I gave this answer, full credit, like I said, 3 decimals to the right of the decimal, rounded or truncated. Truncated just means you cut off the other stuff. Full credit, okay? If I gave this as my answer, not correct. If I gave this as my answer, not correct, okay? There's only 2 decimals to the right of the 0. So we'll practice this a little bit today, and I'll keep reminding you, but that's the standard. Okay, so you guys have any questions on 1A? I really wish we could have fully closed that one off yesterday, but class ended. And although sometimes we don't start class on time, we must finish on time, right? Okay. We good with 1A, unless there's maybe any other questions?
What was the answer? It's 1.5.
For 1A, I think it's the 0.105. Is that good? Is that okay, Joe?
Yeah.
Okay. Okay, so then 1B, obviously doesn't 1B use the same word? Acceleration. But how is 1B different from 1A? It's at a time, right? It's a single point of time. It's not an average acceleration over an interval. It's at a point of time. So what am I kind of forced to do here because of that? I've got to use the derivative. That's the only way I can find acceleration at a point in time. So with that, I would say A of t equals v prime of t. And let's check your derivative here. Did you guys get negative 2t to the negative 3 plus 1 over t? And then, gosh, should be what? Plus pi over 2 sine of pi t? Does that look about right? Feel free to say something if that doesn't look right. Y'all okay with this? Where did that extra pi over 2 come from? Chain rule. You're right. You're right. Okay. So that's the acceleration function. If I want to find a of 5, now it is time to plug in the a. So I would say a of 5 equals, I'll try to do a little simplifying as I go. So 5 to the negative 3 would just be over 125. So I'd say negative 2 over 125 plus 1 over 5 plus pi over 2 times, what is sine of 5 pi over 2? Oh, you're giving me the whole thing?
Yeah.
Negative 1, right?
Yeah.
Yeah. So I think negative 1. So if you had minus pi over 2 there, I think we're in good shape. Pi over 2. Right.
Wait, isn't it?
No. I just did. No, we're doing sine. So sine of pi over 2, so it's 0.
No, it's.
Yeah. No, hold on. I am mixing myself up. I've been over here. Have you been watching me? I've been doing this whole time. I've been like in my head.
Isn't it
So
4 pi over 2 and then 5 pi over 2, isn't it?
whenever I'm having one of these moments, you know what I do? I just draw it. So what's this right here? It's pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. I think it's times 1. Does that make sense? Usually I just draw that in my head, but I was like doing it backwards, and I did eat lunch, although it feels like maybe my blood sugar's a little low. Okay. Do you guys have any questions? You can leave it just like that. If you wanted to get a common denominator, which would probably be 250, I guess, you certainly could, but there's no good reason to do that unless you want to just show off your fraction addition skills. All right, how we doing? Question, Hunter.
What if we did part B with decimal as well?
Well, so the instructions didn't say to use the calculator, although A did. So what if you did? I don't know. If it was a quiz, we'd have a major problem if you weren't supposed to use the calculator. And to be frank with you, if the calculator was active, I wouldn't do any of this junk, and I'll explain myself in a couple of minutes.
Okay.
So probably you're okay.
Okay.
As long as you could get to this, calculator or otherwise, we're good.
Okay.
Yeah. Anybody else with a question? Okay, beautiful. Let's take a look at number 2 then. Number 2, talking about position and velocity and acceleration, all that stuff again, except this time you got a graph. You don't have a nice function, clearly a piecewise graph. I'm only asking one question. It says the position moving along the y-axis is modeled by y of t with the graph of y of t down below. What is the velocity of the particle when t equals 2? And then we'll talk about how you arrived at your answer. So please check out number 2. And I would encourage you, bless you. Listen, I would strongly encourage you to do this. You might be able to come up with a numerical answer pretty quick. Please practice writing down your reason. Don't just say it in your head. Don't just say it out loud. Practice writing it down. Have you ever been there where you're thinking something and you go to write it down and all of a sudden your words are all jumbled up and you can't figure out how to write it? This is a great opportunity for you to practice and hopefully do a great job. Or if you don't do such a great job, we can work on the wording, get it smoothed out a little bit. So looking for the velocity of the particle at t equals 2. And then let's make sure you write down how you got the answer that you got. What you doing, Merrick? What's that? What are you doing with your phone? You're not playing music, are you? I asked you one time. I should not have to ask you twice. You're bored? You're bored? You have a quiz retry hanging out there that's a boat anchor on your grade and you're bored? Oh, I thought you said you were, was that her? You shouldn't be chilling. If I were you, I'd be going back and reviewing. If I had an extra 2 minutes, I'd be like, man, I gotta be better. At least on that one. All right. Anybody from Jackson, Tyler, or Carson's table have an idea what the velocity of this particle would be when t equals 2?
I said 1.
Tyler says 1. Oh, Carson's giving you the head nod.
Nice.
Jackson, oh my goodness. So all three of you think that the answer is 1. So would you guys be okay if I wrote v of 2 equals 1? What do the rest of you guys think about their collective effort? That's good stuff. Man, you guys are getting a lot of head nods. Okay. Anybody care to explain? What were you looking for when you came up with this v of 2 equals 1 thing? What do you look at, Hunter?
The slope of the position graph at that certain time equal to the velocity at that time.
Yeah, it's all about the slope, isn't it? So if you said, yeah, the slope of the position graph equals velocity at that time, sure. That's pretty good. Can I ask you guys a couple of follow-up questions? Is there any places where you feel like the velocity would be 0? T equals 7. Don't we have a nice horizontal tangent line right there? Be a place where velocity is 0. Can you guys see any place where it's probably just not a very realistic graph, possibly? The 2 sharp points, yeah, 0 and 5. I mean, we didn't call those sharp points. They sure look like it. I don't think we can have a particle that changes direction in no time at all. So I think those are probably a little unrealistic given the situation, but maybe this is the future and we just don't know about this yet. Who knows? Anyways, it's a really great response. Do you guys have any questions there? Okay, please get out your calculators. And you are about to have the light bulb on something come on real bright. Excited for you guys. Yeah. How about that? Okay, so let's take a second and read the actual question there on your sheet, and then we'll get to the calculator. So it says the velocity of a car is modeled by v of t. And if we're honest about this, v of t is a little unpleasant, isn't it? That's e to the cosine squared of t minus ln of t plus 2 meters per second. And we're supposed to be including units with these. Well, then we get to part A, and it says, find A of 4 using Math 8. So something I'm guessing some, if not all of you, have never seen before. So this should be really awesome. So on your calculators, here's what I want you to do. I want you to push, literally, Math, then 8. And when you push those two buttons, one after the other, what comes up? Oh, look at this. It's d blank of something evaluated somewhere. So what your calculator will do is it will calculate the numerical value of a derivative evaluated at whatever point in time or location we need. So I want to say this. This, of course, is no substitute for you knowing what the derivative of cosecant is. Because, of course, there will be certain quizzes and tests where the calculator is not active. This will do you no good, right? But there are definitely going to be times, just like number 3A and really 3B as well, that the calculator will be immensely helpful, and some might even say necessary, especially considering time constraints and such. So here's how you use this. I'm going to go ahead. I know that we're technically doing ddt of everything, but I'll go ahead and use the x input. I'll make that my inputs here. So I'm going to say I want to do ddx of, and what do you think I put inside the parentheses? V of t, right? Because I want to do the derivative of v of t to get to my acceleration, and then I'm going to plug in a 4, right? Because I want a of 4. So I'm going to go I'm going to go cosine of x double close squared minus ln of t plus 2. So it'd be x plus 2. So at this point, I'm telling my calculator, I want you to do the derivative of velocity, which we all know is going to get us to acceleration, bless you. And then I'm going to plug in a 4. So I just scroll over to the right, and I say add x equals 4. And then you know what your calculator is going to do. It's going to find the derivative of whatever you put in there, and then it'll put in a 4 and evaluate all that, and it'll spit out an answer. There you go. Seriously, right? Isn't that awesome? So my comment to you earlier, Hunter, maybe makes sense, right? If the calculator is active, there is no compelling reason for you to go term by term and use all your derivative rules. I have all the reason in the world to just go math 8, plug it in, and x equals whatever, hit enter, and done. Now, no calculator section, you got to go term by term. You've got to use all your lovely derivative rules. You want to make sure you actually know what's actually happening there. In a lot of these cases, especially applications, we're just going to use math 8. It's going to take you 45 seconds to do this difficult derivative, and you'll be done. Cool? It even knows how to do the chain rule, the product rule. It knows how to do all that stuff. Anyways, is that good news? Sometimes, yes, no?
It's pretty sick.
It's very cool. It is very, very cool. And there's a couple of other unique features to your calculator that we'll look at throughout the year as well. I've waited a long time to show this to you, and I think some of you totally understand why. You're going to have a serious temptation from here on out, and here's going to be the temptation. Maybe it's WebAssign or something, and it's going to be a numerical derivative. You're going to be tempted to always use Math 8 whenever you can feasibly make it work, right?
Yeah.
Don't let that make you super lazy to the point where you forget what the derivative of tangent happens to be, or what the derivative of natural log of 5x squared plus 10x minus 9 would be. Because I guarantee you, there will come a time on some test or quiz where I will say, hey, no calculator allowed, what's the derivative of secant of x? And if you've gotten super lazy because all you've ever done is Math 8, you're going to have a hard time answering that question. So I'd encourage you to do it this way. This would be the mature way to do it. If you need practice on your derivatives, put the calculator away. If you're good, if you have all those things absolutely rock solid and you know you do, and you want to use Math 8, maybe more power to you, right? So be wise, and I think you'll be served well in both cases. Anyways, so there you go. So A of 4 is, by the way, did we all get the same answer? What would be one serious trap to watch out for here? Your parentheses is a big one. What else? Yeah, with the parentheses, right? If you didn't have enough parentheses, it would be, is the x being squared or is the output being squared, for sure. There's something else that I'll always remind you of when we do a quiz or test with the calculator.
Mode gradient.
It's mode. Mode. So this one has a trig function. So if you happen to be in degree mode, seriously would get this wrong for no good reason. It was just because you're in the wrong mode. Not cool. And so I'll try to remind you that. So be on the lookout for that. So I've got one. I really would like to get to number 4, and we might get to part of number 4, but I've got one last big thing about speed and velocity and acceleration and position and all that to get to, and that's 3b. So don't write anything down yet. I just want to hear you say it, what you think. So B says, is the speed of the car increasing or decreasing at t equals 4 seconds? Give a reason for your answer. So this is obviously a binary thing. The answer is either increasing or it's decreasing. And that's why you've got to give an answer or a reason for your answer. So I just want to say this. If this were a quiz question, and let's say the answer, I don't remember the answer to be honest with you. Let's say the answer is yes, and you just write the word yes and you don't give a reason. Even if the answer is yes, you're getting no credit whatsoever. Because all you did was guess. And maybe you didn't know the reason, or maybe you just like took a shot in the dark and got it. So you've got to give a reason with your answer. I'd like to hear what you think. Hunter, increasing speed or decreasing?
Decreasing, since there's a negative acceleration, which means there's a negative slope on the velocity graph.
So he just used some really excellent language. I think he clearly stated what he wanted to say. I think it was extremely clear, but it's a tiny bit misguided. He said, I think speed is decreasing because acceleration is negative, which would be a negative slope on the velocity graph. Basically just quoted you, well said, but not quite where we're going. Zach, what do you think?
Well, speed could still be positive with a negative acceleration if the object is decelerating, so you would find v of 4, rather so to find the velocity at 4 seconds.
So you're saying v of 4 is important
Yeah.
in this consideration as well.
Negative, so the speed would be negative.
Interesting. Okay. I'll come back to that for sure, Luke.
Well, speed's not a vector.
Right?
It's velocity, so like you would take the absolute value of velocity.
Okay. Absolute value of the velocity graph does give you a speed graph. I'll give you that. So he said speed's not a vector, right? So again, Zach, I'm going to come back around to what you said. You said speed
Or,
would or wouldn't be negative.
sorry, I meant velocity.
So yeah, so velocity could be positive or negative. Speed, however, is always non-negative, right? Speed could be 0 or positive. That's it. Carson, what did you want to say? Or did?
I have a question about it, but you answered it.
Okay. Okay, fair enough. Reese?
OVT is decreasing because if your acceleration was decreasing, then your speed would have to be decreasing.
If your acceleration is decreasing,
Yeah.
your speed would have to be decreasing. Whew, if acceleration is decreasing, we're now talking about jerk, aren't we? Yeah, we are.
Right.
If acceleration is decreasing, that means the rate of change of acceleration is negative. The rate of change of acceleration, that's jerk. Now, if you wanted to tell me acceleration was negative, therefore blah, 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 I could go maybe with that. But if you're going to tell me acceleration is decreasing, you're telling me that its rate of change, aka slope, right, is negative. Now we're talking about that next level down called jerk. I don't think we're never going to go there. If you find yourself thinking, what are the units for jerk? You're in the wrong place, for sure, in this class at least.
So the acceleration at 4 is negative, right?
Acceleration at 4 is definitely negative.
So like you could be getting like you could be decelerating. It kind of
Let's never ever use that word. It's really confusing. Never use that word. You can accelerate in a positive direction or you can accelerate in a negative direction. I'll give you that.
Doesn't it kind of depend what velocity you started at?
It does. So you led us into a great place. Can I give you guys an ultra high-tech demo here? It's basically me just walking around. Okay? And it's also a call to you to think about what the gauge in your car is. So the gauge in your car is not called a velociometer or that. It's called a speedometer, right? Okay. So for you guys, this direction is right. And that's left, isn't it?
Right.
Okay. So can we say that that direction is positive motion?
Sure.
And that direction is negative motion? All okay with that? Okay. So if let's say I start right here, and I start walking this way, my velocity is positive. Let me start over. So I'm starting right here. Remember, that's the positive direction. That's the negative direction. So if I start walking this way, my velocity is positive. Now, we don't know what it is exactly, other than we know it's positive. If I'm in a car and I hit the gas pedal, wouldn't I be doing this? So I need you to think about this for a second. So I started off right here, and you all said right now my velocity is positive. I hit the gas pedal and I accelerate, so my acceleration is positive, so my speed was positive. Speed, we don't refer to speed as positive or negative, we'd say speed would be increasing. So pretend you're in your car. if you're in your car and you're just idling along forward, isn't your velocity positive? And then you hit the accelerator, what does your speedometer do? You're speeding up, aren't you? Okay. So if my velocity is positive and my acceleration is positive, would you agree with me that my speed is increasing?
Yes.
Okay. There's a whole different scenario, and I don't encourage you to do this unless you're in a really wide open space. Your car has a speedometer. So if you're, pointing this direction and you put your car in reverse, my velocity is, believe it or not, if you're going in reverse, your speedometer should register speed. Right? Hopefully it doesn't hit like 50. Right? Hopefully it's just like 5. But if you're going backwards, even though your velocity is negative, isn't your speed showing up? Right? Okay, so I'll start over here again. So if I'm walking this way, my velocity is negative. If I were to hit the accelerator, wouldn't I do this?
Yeah.
I didn't trip. Bonus point number 1. Didn't I speed up? You all saw me. I mean, I know I'm not quite that fast, but I sped up, didn't I? So think this over. If my velocity is negative and my acceleration is negative, my speed's increasing, isn't it? Who knew? So just because acceleration's negative is not going to give us a definitive answer. As was suggested by maybe a couple of you, we need to look at velocity as well. So let's take a minute and do that on our calculators real quick. On the calculator, let's calculate v of 4. So I'm kind of locked onto my writing screen. So if I could get you kind folks to do this for me on your calculators, calculate what v of 4 would be. So it'd be e to the cosine of 4 quantity squared minus ln of 6. Now let's see what that number comes out to be. Negative what? Let's do the 3 decimal thing, so 259.
Mm-hmm.
Okay. So negative 0.259. So we can go back up here and say, well, acceleration at 4 was negative. Acceleration or velocity at 4 was also negative. So, gosh, since both acceleration and velocity at that point in time were negative, speed is doing what? Increasing. Speed is, now somebody's got this car in reverse and they just hit the gas, so they might crash, but their speed is increasing. Here's how you would give a reason for your answer. You would say A of 4 and V of 4 are both negative. Therefore, speed is increasing. I hope that the opposite of this is clear. What if acceleration was positive, but velocity was negative? What if they're heading in different directions? Speed is decreasing. You're slowing down. That's right. So another key takeaway here would be if velocity and acceleration have different signs, speed is decreasing. The number one struggle that students have here is forever in their whole lives, they've thought of as velocity and speed as being the exact same thing. They're very related, but they are not necessarily the exact same thing. So we want to kind of separate those two out. Okay, so number 4 had some lovely IVT implications and all, but we're clearly out of time. So maybe we'll pick those up some other day, maybe review day coming up or something. So have a great rest of your day. Appreciate working with you guys.